math. Okay. All right, so today's going to be our final webinar, which is going to be on hard math. So this is going to be a little bit like a bonus webinar. It's going to be kind of different than the ones we've had before. So for those of you who went to the other webinars that we had, so those were like very presentation heavy. So for this one, we're just going to do like a very brief introduction, literally just one slide. And then after that, we'll finish up the grid-in questions from the no calculator section that we didn't get to do at the regular math webinar 2 weeks ago. And then after that, we'll look through some of the harder and more medium hard questions from the calculator section. So we'll definitely look through some of the harder multiple choice. So we're going to start at around question 18. And then if we have time, we may look at some of the grid-ins. So we might not get to the grid-ins today, or if we do, we might have to skip to some of them at the end. So we'll see how the timing is. All right, great. So first, I just wanted to give just a general overview about the hard questions on the test. So overall, only about 12 out of the 58 questions or so will be what are officially considered hard questions. And they're generally found towards the end of the multiple choice and grid-in sections. So in general, the easier questions tend to be the beginning, the more average ones in the middle, and then the harder ones at the end. However, the difficulty level, as you know, is going to vary by test, and not all hard questions are necessarily created equal. So just a few things I wanted to highlight before we move on to the test. So one is that some medium questions might actually give you more difficulty than certain hard ones. And by medium and hard, I mean like what the College Board actually rates each question as easy, medium, or hard. But I wouldn't necessarily take those ratings too literally. So to just give one example, a student who I worked with last year on his May exam, he took it last May for real, and he got 55 out of 58 of the math questions right, which is really good. So when I heard he only got 3 wrong, I expected them to be like really tricky ones, maybe ones at the very end of the multiple choice, for example. But to my surprise, 2 of the 3 questions he got wrong were pretty average level multiple choice questions right in the middle of the calculator section. I think it was questions 15 and question 16. So I was a little surprised to see that he got those 2 questions wrong while he got all of the ones at the end right. But when I looked more closely at those questions, it actually didn't surprise me that much. So those 2 particular questions were based on a table that you had to read. And the table itself had some extra information that ended up not even being relevant to answer either question. And in addition, the questions themselves were somewhat wordy. So even though they weren't necessarily that hard, I could imagine the student, in the moment getting a little bit nervous and maybe not reading everything fully, and then making an error that was somewhat careless. So I think that's what happened to him. He probably just got a little bit flustered and didn't fully read everything. And he didn't realize that the questions were actually probably a lot easier than he had thought. And he was definitely more than capable of getting them right. And then since then, I've done that practice test with some of my tutoring students, and many of them have gotten either one or both of those questions wrong. So they weren't necessarily, they were as easy as they might have seemed on the surface. So just the general point of that is you shouldn't really take questions for granted just because they're considered easy or medium, and you shouldn't necessarily freak out about a question because it's officially considered hard. In general, you just want to work on the skills and concepts that are most difficult for you, not necessarily what the College Board says is supposed to be easy, medium, or hard. So everybody's different in terms of, which questions they find challenging personally. And then the last thing I wanted to talk about is kind of some of the key features that distinguish hard questions from other questions. So again, like I said, the notion of a hard versus medium question itself is somewhat subjective. But I would say that in general, most of the questions that are considered hard are actually relatively simple to solve. They just generally require maybe more specialized or advanced knowledge than the average student has. So if you study a lot, then you should be fine on most of these questions. But these are questions that students who maybe aren't doing formal test prep are likely to get wrong, either because maybe they didn't learn it in their math class or they haven't studied it in a while. That being said, there are questions that could be hard for other reasons. So for example, there are a handful that might require some more convoluted algebra or computations. So even a student who knows what they're doing could still make a mistake along the way. And we're actually going to see one question like that today where there's a lot of computations involved. So even a student who knows what formula they're supposed to do and does almost everything perfectly can make one little error that's going to throw the whole answer off. Another reason a question could be hard is just because it puts a lot of demands on your working memory. And remember, working memory, we talked a little bit about this during the reading webinar. It's all the information you're trying to keep track of in your head at a given time. So in this case, questions that involve long word problems, especially if they're accompanied with graphs or charts, like the one that gave my student difficulty, those could be questions that could kind of be overwhelming. And it's possible that you might just kind of freeze when you see them and not really read them carefully and then end up struggling with them, even if the math itself isn't that difficult once you kind of take your time. And then finally, there are a handful of questions that do require sort of genuinely creative and flexible thinking. These questions have mostly been eliminated. For the most part, the questions are pretty straightforward now, but there are a handful of questions that do kind of reward cleverness and, kind of seeing the deeper structure and expressions. And we will see a handful of questions like that today that sort of reward creative thinking. However, even many of those questions, they'll tend to repeat some of these question types from test to test. So once you see one question that might come off as a little bit weird and strange, if you kind of study it well, you might be able to recognize when you see a similar question to that in the future with slightly different numbers or in a slightly different situation. So that's pretty much all I wanted to say generally about the hard math questions, because we've already talked pretty extensively about the math section in general at our other webinar. So I'm going to now go to the test where we left off. So we already did all the multiple choice of this together at our regular math webinar. So we're going to start with number 16. So this is our first grid in question. So here we're given the question, the equation 14 minus 8d is equal to 12h. And they're telling us the equation can be rewritten as t equals ad plus bh, where a and b are constants. They're asking us for the value of a. So a common question I get with this question in particular, and questions like it, is some students get confused what they mean by constants. They just mean that a and b stand for some sort of fixed value. So it's not a variable. That can be any number I want it to be. A and b actually stand for two real numbers, and we have to figure out what they are. In this case, we only need to figure out what a is as far as answering the question. So in this case, I have this equation that's 14 minus 8d is 12h, but I need to rearrange it so that it's in the form t equals ad minus bh. So this is a pretty classic passport to advanced math question where essentially you're given one equation and then you need to rearrange it to get one of the variables by themselves. So this is a fairly simple one as far as these question types go. There are some that could get a lot more convoluted that maybe involve division and radicals and squares. So this one's fairly straightforward. So the first thing that you can do is you could add 8d to both sides. So then you would get 8d plus 12h. You also could have done 12h plus 8d. Doesn't really matter since addition is commutative. I just put the 8d in front to have it match the form that they want us to have here. And then finally, we could divide everything by 4. So that leaves us with t is equal to 2d plus 3h. So they want to know a, which is a coefficient to our d term. So then 2 would be our final answer to this question. You also could have divided everything by 4 in the beginning and then added, in this case, 2d to the other side, and you would have gotten the right answer as well. All right, so number 17 is a question that I would say is arguably one of those more creative thinking questions in a way, because it does involve a little bit of visualization. So some of the harder geometry questions will require you to kind of rearrange shapes or break them down into simpler shapes. So these questions don't show up a lot anymore. They used to be very common on the SAT before 2016. Now they're a lot rarer. So a general concept you could remember for this particular shape that's going to come in handy for trapezoids is that if you ever see an isosceles trapezoid, that can be broken down into a rectangle and two congruent right triangles. And then you could find the non-parallel sides of the trapezoid by Pythagorean theorem. So that's kind of a general thing you can remember. But we'll take a look at this question and you'll see what I mean. So here we're given a picture of this trapezoid, and they tell us that BC is parallel to AD and that AB equals CD. So that's how we know it's an isosceles trapezoid, because we have two equal non-parallel sides. And they want the perimeter of ABCD. So perimeter is all the sides added together, but I only am given two of the sides directly. So I have AD is 26, I have BC is 10. So I know the perimeter is at least 36, but then I have these two equal sides that I'm not actually given. So what I said, like what I showed you before, is we could break the shape down into a rectangle and then two congruent right triangles. This is a general thing you could remember if you ever see the shape in the future, even with different numbers. So now we have one rectangle and we see that the base is 10, and we know that opposite sides are congruent. So I'm going to actually call this rectangle BC. Actually, I'm going to add an FE in there just for labeling purposes. So I could say that EF is also 10. So I know that AD adds the 26 altogether. I know my EF is 10. And then I know AE and FD must each be equal to each other. So I have 16 left over in my base. So then each of these must be 8. So you can see that makes sense because 8 plus 10 plus 8 gets me back to 26. And then the height I know is 6 because they show us that here. So now that we have these two triangles with a height of 6 and a base of 8, we could find the hypotenuse. So you might already memorize what the hypotenuse is if you know your Pythagorean triplets. But if not, that's fine. We could do the Pythagorean theorem, which they give to us on the reference table, which is c squared equals a squared plus b squared. So I circle that for you. So c squared represents the hypotenuse, and then a and b are the legs. So in this case, I know both legs are 8 and 6, but I don't have the hypotenuse. So I would do 8 squared plus 6 squared equals c squared. So I would end up with 100 is equal to c squared. And then 10 is equal to c. So a, b, and cd are each equal to 10. So the perimeter is just all four sides added together. So that's just 10 for AB, plus 10 for BC, plus 10 for CD, plus 26 for AD, which altogether gives me 56. So again, this question is one that definitely gives a lot of students difficulty, but if you recognize that you could break it down into a rectangle and two triangles, then it becomes, not that difficult of a question. And this is just a general thing that I would keep in mind if you ever see a question like this again. It's probably not going to be this exact numbers. It might not even be the exact question. Maybe they'll ask for something different. But in general, though, you could find the missing sides just by kind of breaking it down into the rectangle and two right triangles like we did here. All right, so 18, this is going to be an example of a hard question that just requires a lot of algebra. So here we're given this quadratic equation, x squared minus 2x minus 1 equals 0. And they tell us the equation above has a solutions, x equals n plus radical k and x equals n minus radical k, where n and k are positive integers. So we want to know what the value of n plus k is. So the reason they had us put it in this form is because we can't enter radicals into our grid and sheet. So they just want to know what the number is in front of the radical, what the number inside the radical is, and add them together. So how are we going to go about finding this? So sometimes students think that they need to factor, and oftentimes that is what we need to do with quadratic equations, but they gave us one really big clue here that factoring is not going to work, which is the fact that our answer is in radical form. So typically, if they ever give you a quadratic equation and they want the solutions to involve radicals, you're not going to be able to factor. So two ways you can solve this. So one way which you can do, which I'm not going to show you today, is you can complete the square if you're comfortable with that. Or the other way is you could use the quadratic formula, which is something that they don't give you, so you would need to memorize that. So to save time, I actually did all that work out here. So here's the quadratic formula for any equation that's in y equals ax squared plus bx plus c form. So that's x equals negative b plus or minus the radical, b squared minus 4ac, all over 2a. So that's a formula you're going to have to memorize. So for our equation, we had x squared minus 2x minus 1. So in this problem, a would be 1, because that's the coefficient to our x squared. B would be negative 2, because that's the coefficient to our x. And then c would be negative 1. So that's our constant term. That's not a variable. So here, I just plugged in all of my terms in for a, b, and c as appropriate. So as you can see, this is a lot of math involved, so it's very easy to kind of make an error along the way if you're not careful, even if you know what you're supposed to do. And then after you do all these computations, you end up getting 2 plus or minus radical 8 over 2. So some students do get to this point actually, and then they kind of get stuck because they know it's not the simplest form because it doesn't align with the way our question needs to look. So what we do is you might remember from your Algebra 2 class, if you've taken that, when you have a square root, if it has a perfect square factor, you could actually break it down into its perfect square factor and its non-perfect square factor. So in this case, 4 is a perfect square that goes into 8. So I could divide radical 8 into radical 4 times radical 2. So since radical 4 times radical 2 equals radical 8, then you might notice that the square root of 4 itself is just 2. So then my equation ends up, or my expression ends up being 2 plus or minus 2 radical 2 all over 2. And then finally, I could divide the 2 that's before my plus and minus sign by the 2 in the denominator. And I could also divide my 2 radical 2 by the 2 in the denominator. And then I ultimately end up with 1 plus or minus rad 2. So this would be the simplest form. So then we see now we're finally in my n plus minus rad k form. So n in this case we see is 1, k we see is 2 because that's a number in the radical. So then n plus k would just be 1 plus 2, which equals 3. So again, this question was very straightforward. There was no trick to it. It's, it's just a procedure, but there is a lot of steps involved. So you need to memorize a quadratic formula. Then once you memorize it, you need to plug in everything correctly. And then once we plugged in correctly, you needed to know how to simplify radicals and then kind of make sure you simplify further. So there are a lot of steps along the way where you could have made an error. So if this is something that you're not comfortable with, this is definitely a topic you're going to want to drill more. All right, so now we'll go to number 19, which I say is a more medium level question, but it's one that shows up every test. So it's important that we go over that. So here they give you the system of linear equations. So they tell you 4x plus y is equal to 7 and 2x minus 7y is equal to 1. And xy is a solution to the given system of equations, and they want you to find the value of x. So anytime you're given a system of linear equations in ax plus by equals c form, there are two approaches you can use to solve this. So the first one is substitution, which I generally don't find the easiest to do, but I'm going to go through that method with you as well as the other one. So in substitution, what you would do is you would rearrange one equation to get one of the variables by itself. So I actually wrote out that work for you. So my top equation, which was 4x plus y equals 7, you could subtract the 4x to make it y equals 7 minus 4x. So now that we know y is equal to 7 minus 4x, I could replace y in the bottom equation with 7 minus 4x. So in place of 7y, so I had 2x minus 7y equals 1, but I just replaced the y with 7 minus 4x since that's equivalent to y. And then I distribute and I end up with 2x minus 49 plus 28x equals 1, 30x equals 50, and divide both sides by 30 to get x equals 5/3. So you could do that method and that's perfectly fine. However, I prefer to use the elimination method in most cases because substitution could sometimes get a little bit messy. So in this problem, it wasn't bad, but like, let's say you had a 3y, for example, instead of y, then you'd end up with fractions involved and that things could get really convoluted. So the elimination method, which is the way that I personally go about solving these, is I try to multiply either one or both equations by a constant that will result in one of the variables being the negative of the other variable. So when I add the equations together, one of the variables will disappear. So like if I were to try to add the equations together now, the way that they're actually written, I would have 4x plus 2x is 6x, y minus 7y is negative 6y, and then I would have 7 plus 1 is 8. And then I end up with like 6x minus 6y is 8, and I can't really do anything with that. So that doesn't help me very much. However, if I multiply the top equation by 7, then you'll notice my top equation now becomes 28x plus 7y equals 49. So if I multiply everything by the same term, I don't change the value of anything. And in my bottom equation, I just kept the same in this case. So I had 2x minus 7y equals 1. Now, if I add the equations together, I get 28x plus 2x is 30x. 7y minus 7y is 0, so that goes away. 49 plus 1 is 50, and then I still end up with the same answer. So I divide both sides by 30, and I get x equals 5/3. So I usually recommend this method when the equations are in this form, but it's still good to know both methods. So you just kind of have to be flexible in terms of the numbers that they give you to see which is most convenient. But when they're structured like this in the ax plus by equals c form, then I typically prefer to use the elimination method, but substitution would have worked perfectly fine as well, as we saw. All right, so then the last one for the no calculator section is 20. So this is an example of what I said would be a hard question that's actually not that hard if you know the rule. It's just that's a rule that a lot of students forget. So here they tell you in the given equation, k is a constant. So again, k stands for some real number that we need to figure out what it is. And they tell us the equation has no solution and we need to find the value of k. So the rule that this question is based on is pretty simple. So linear equations have no solution when the slopes are equal, but the y-intercepts are unequal, which means that the lines are parallel to each other. So if you were to kind of like draw two lines with the same slope but different y-intercepts, they'd look something like that, and they would never touch. So solutions are where the equations touch. So if they're parallel lines, then they're never going to intersect. So in this case, I'm just looking for the slopes to be equal. So I notice that on the left side of my equation, the slope is 1/2. So that means that the right side of my equation, k also has to be equal to a half. So you see this one arguably was the easiest one to do because it only took a few seconds if you knew the rule. It just happens to be a rule a lot of students don't know, which is why it might be considered a hard question. And we can confirm that it's no solution because if you actually tried to solve this just to see what would happen. So sorry, that shouldn't be a minus there. So you would end up getting, if I subtract 5 from both sides and then subtract a half x, you end up getting 0 equals 2, which doesn't make any sense. So there's no solution. All right, great. So that's it for the no calculator section. So next we're going to start looking at the calculator part. So as I told you before, the way the test is structured is the easier questions tend to be towards the beginning. So I'm actually going to start at question 18, which is right in the middle. So I would say 18 is probably technically a medium level question, but like I said, some of the medium level questions are worth going through. So we're definitely going to do 18 through 30 today. And then depending on what time we end, we may do a few of the writtens, which are questions from 31 to 38. So number 18, I wanted to point out for you. So this might look very similar to question 19, the one that we already looked at. So x plus 2y equals 10 and 2x minus y equals 5. And they say the solution to the given system of equations is x, y. They want to know the value of 3x plus y. So one way you could do this is the exact way that we did number 19. You could do substitution or elimination and find either x or y. In this case, you actually don't even have to do that. This is one of them that's kind of rewarding cleverness. So anytime a question like this asks you not to find x or y individually, but some expression in terms of x and y, like 3x plus y or 2x plus 5y or something like that, there's a good chance that you could actually not need to find x and y, and you could just either add or subtract the equations. So to show you what I mean, the first thing I would do if I see this as a question is I would just add the equations together the way they're written now, just to see what happens. So if I do x plus 2x, then I get 3x. And if I do 2y minus y, I get y. And if I do 10 plus 5, I get 15. And then look, that's actually already the final answer. So I didn't even need to find what x and y were. Just to point out a few ways, though, that they could have made this question a little bit more difficult based on what they've done on past tests. So the way this could have been made into, so I would say this is a more of a medium question. The way they could have made it a little bit more difficult is maybe they would have asked you to find a multiple of 3x plus y. So maybe the question would say, find 6x plus 2y. So after adding, you would have to recognize, oh, 6x is twice 3x, 2y is twice y. So then the other side of my equal sign must be twice 15, which is 30. If they wanted to be even more difficult, they might give you a factor. So for example, they might do something like find 3/4 x plus 1/4 y. And you'd have to recognize, oh, 3/4 x is just 3x divided by 4. And 1/4 y is y divided by 4. So then I must be doing 15 divided by 4. And then a way they can make it even trickier, which I've only seen them do on one test, is instead of adding, you might have to subtract. So maybe they would say, find negative x plus 3y. So if I subtract my original equations, x minus 2x is negative x, 2y minus negative y is 3y, and then 10 minus 5 is 5. So these are just kind of ways to kind of get thinking a little bit more flexibly and know some of the common, question types that they tend to ask. All right, so the next question we're going to look at is 19. We're going to talk about this topic in a little bit more depth when we get to 27, but we'll do kind of a brief introduction to it now. So here it tells you an advertising agency guarantees that its services will increase website traffic by 3.5% compared to each previous week. Which type of function best models the weekly guaranteed website traffic as a number of weeks increases? So we know that the traffic's going up by 3.5% each week compared to the previous week. So it's pretty obviously going to be an increasing function. Decreasing would mean it would be going down. So I could get rid of B and D. So sometimes students just aren't sure whether it's linear or exponential. So with linear functions, you're actually going up by a constant number. So that might be like going up by 3,000 visitors a week, for example. Whereas with exponential, you're going up by a constant percent, which is the same thing as multiplying by a constant number. So A would be correct. And then when we get to 27, we'll actually kind of look mathematically at how we would represent this. And then we'll come back to this question after, and I can kind of show you how we would represent that. But in general, if you're going up or down exponentially, it means you're changing by a constant percent. If you're going up or down linearly, it means you're changing by a constant number. All right, so for number 20, This is a scatter plot question. So again, this is a very medium level question, but a lot of students, especially those who haven't taken maybe a stats course, are often a little bit confused about how to interpret these. So in general, scatter plots show you something that's called a line of best fit. And that's just a predicted value of y at any given value of x. So for example, if we look here at this point I circled, this is showing us that when x is 15, we have some sort of linear model that predicts y should be about 30. However, in real life, our data doesn't always match our predictions exactly. In fact, it usually doesn't. So the dots represent our actual data points. And you notice that they might either be on the line, above the line, or below the line. So when it's below the line, it means that our model overestimated the real value. So for example, if we look at where x is 10, we see the line, predicts that y will be somewhere like 20, but we see this point here is below that. So the line was an overestimate. On the other hand, if a dot is above the line of best fit, then that means that the line underestimated its real value. All right, so the question here, they're just asking, so they're telling us a scatter plot shows a data set of 11 points and a line of best fit for the data. For how many data points is the y value predicted by the line of best fit greater than the actual y value? So the actual y value is the dots. So we're looking for any time where the line is above the dot, meaning that would be 1, 2, 3, 4, 5. So we have 5 of those points. So again, the line kind of overestimated, in this case, the real values. All right, so 21 involves function notation. So I'm just going to do a quick review of that before we look at it. So you might remember back when we did question 14 2 weeks ago, the no calculator section, we talked a little bit about function notation in the context of graphs, but now we're going to talk about it in the context of word problems. So in general, if you're ever told that f of a equals b, that just means that your x coordinate is a, so whatever number's in that parentheses is a, and then number on the other side of your equal side, which in this case would be b, would be like your y coordinate. And remember that f would be another name for y, and other functions might use other names other than the f. They might call it like g of a or h of a. No, it doesn't really matter. The key idea is that the number in your parentheses is your x, the number on the other side of the equal is your y. So that's the most important thing. So pretend you were given this function f that shows the relationship between the predicted number of customers at an ice cream shop as a function of temperature in x degrees. And then you're given this function f of x equals 100 plus 9x to show that relationship. So basically this is showing a positive linear relationship. So it's predicting that basically the hotter it gets out, the more customers you're going to have for ice cream, which would make sense. So let's say they tell you that f of 10 equals 190, and they ask you to interpret that in English, in words. So in this case, 10 represents my x value, because that's a number in parentheses, and x is temperature, and then 190 is my y value, which is customers. So I would interpret this as when my x value, or temperature, is 10 degrees, my predicted y value, or number of customers, is 190. And you could pretty much use this template for any question, for any sort of function. So let's take a look at 21. We'll read the question, and then we'll go over how we would interpret it in our own words before we even look at the choices. So it says here, Dana is riding in a 100-mile-long bicycle race. The function f is defined by f of x equals 100 minus 18x. So the function f defined by f of x equals 100 minus 18x models the number of miles that Dana has remaining x hours after she starts the race. So they want to know the best interpretation of f of 2 equals 64. So again, we see that 2 is my x value. See that 64 is my y value because they're my x and y positions. And they define x for us as a number of hours after she starts the race. And they define y for us as a number of miles remaining. So I know that 2 is x, which is my number, the number of hours after she started the race. And 64 is y, which is a number of miles she has remaining. So I'm trying to look for a choice that tells us that. And the only one that really does that is D. So 2 hours after she starts the race, so that's my x, she has 64 miles remaining. That's y, so D would be correct. So you see other choices might look kind of similar, but they're not quite the same. So like C, for example, is saying she's ridden 64 miles, but remember, y is not how many miles she rode, it's how many miles remaining. So I really kind of recommend this approach, figuring out what your x is, what your y is, and the units in your own words, and then looking at the choices to try to see a match. That could be a very useful strategy, similar to on the reading section where we said how predicting answers in your own words could often be helpful on that section. All right, So for 22, before we look at that, I just want to go over a few just general reminders about some rules. So remember, congruent triangles are triangles that have equal sides and equal angles. So it's basically like two copies of the same triangle. Whereas similar triangles, they have equal angles, but proportional sides. And if two angles in a triangle are equal and at least one side is equal, then we can prove that the triangles are congruent. So here we have the situation where we're given these pictures of these two triangles. And it says triangle ABC and triangle DEF each have an angle measuring 29 degrees and an angle measuring 54 degrees as shown above. So they want to know which of the following statements is sufficient. So sufficient means enough by itself. So not just necessary, but sufficient to prove triangle ABC is congruent to triangle DEF. So we want to prove that these are congruent, not just similar, but that they actually have both equal sides and equal angles. So before even looking at the choices, one thing that I'm going to do just out of habit, one thing you want to remember about triangles, and they actually give you this fact on the reference table, but I do recommend memorizing it, is that the sum of the interior angles in a triangle, as they tell you here, is 180 degrees. So anytime you see a triangle and you're given two of the angles, just as a habit, I think it's a good idea just to fill in the third angle because it's probably going to be important. So in this case, we have two of the angles are 29 and 54. And I know all three angles have to add to 180. So on my calculator, all I would do is 180. Sorry, I didn't want to do that one. Minus 54 minus 29. And you would end up getting 97. All right. Sorry, I didn't mean to use a zoom annotation. All right. So, all right, so these would each be 97. All right, so I just wanted to fill that in just because I know I could find that. All right, so now we'll look at the choices. So B and D we actually already figured out. But again, the fact that they have equal angles only proves that the triangles are similar, not that they're congruent. So I could get rid of those. If I look at choice A, the fact that EF is 10, well, that's good to know. It doesn't really help me if I don't know anything about what side ABC is. So that's not going to help me. But choice C, though, on the other hand, that will help me. So if I know that BC is equal to EF, then I know that they must be congruent because all the angles are equal and they have at least one equal side. So it means that all the sides are congruent. All right, great. So next we'll go through 23. So before we look at that, I want to just review some general concepts about absolute value. And then I'm going to kind of show you a common misunderstanding students have on this question. And I'll show you kind of another variation of this question that they're often confusing this one with, that they do often test on the test though, that I think will be worth going over. So in general, absolute value, as you remember, is the distance of a number from 0 on the number line. So for example, the absolute value of 3 is just 3, since it's 3 units to the right of 0 on a number line, whereas the absolute value of -3 is also 3, because it's 3 units to the left of 0 on a number line. And one thing you always want to remember is that absolute value can never be less than 0. So it's either going to be 0 or a positive number. So if we look at question 23, they're asking us how many solutions does x plus 7, or does the absolute value of x plus 7, equal -4? So like I said, absolute value can never be negative. So that means that there's no solution. So you actually didn't have to do any math for this. However, I do want to point out a common misunderstanding that students have with this question that I think, and the reason they might be having it, because there is another type of question that they tend to ask with absolute value. So a lot of students incorrectly put C. That would have been right had the question said this. If they had said the absolute value of x plus 7 equals +4. And then the way that you would go about solving those solutions, which the SAT does ask you to do, I've seen them ask that on other tests, that does involve working with negatives. And I think that's where some students get confused. So let's just pretend that the question had been the absolute value of x plus 7 is 4, and you had to find those two solutions, which is something that, again, they have asked on past tests. So the first thing you would do is you drop the absolute value sign, and you would set x plus 7 equal to 4, and just solve normally, and you would get -3. And we see that works, because if I plug -3 back in, I get -3 plus 7 is 4, and the absolute value of 4 is 4. And then the other equation that you would set is x plus 7 equals -4. And then you would end up getting x is -11, And then we see that works because if I plug negative 11 back in, I get negative 11 plus 7 is negative 4, and the absolute value of that is 4. So I think some students were thinking about this type of problem when looking at that, and that might be why they got confused, but these are two different questions. So if the original expression is equal to a positive, then you drop the absolute value, and you solve normally, and then you do another equation negating the right side. And then, but if it's originally equal to a negative, then there's just no solution. So it's important that you kind of know the difference between these two question types, but both of which you're responsible for knowing. All right. So then finally, next we'll look at number 24. Oh, and another thing I want to point out with 23. So B would have been right had it been equal to 0. So if the absolute value equals 0, then there's just going to be one solution, which in that case would have been negative 7, because negative 7 plus 7 is 0. All right, so we'll look at 24. This is another question that kind of rewards students who know a fairly obscure formula. So here they give you this quadratic equation, 3x squared plus x minus 2 equals 0. And they tell you the solutions to the quadratic equation above are a and b, and they want to know the value of a plus b. So yeah, there are several ways you can do this. So yes, you definitely can factor this one. It's going to be a fairly annoying one to factor since we have a 3 in front of the x squared. You also could, I guess, complete the square or do quadratic formula. And had they asked you to find what one of the solutions is, you would have to, do one of those methods. However, if they just ask you to find the sum of the solutions, which they often do on the SAT, you could get around doing all that. So there's a really useful formula that you definitely want to remember, which is negative b over a is a sum of the roots anytime y equals ax squared plus bx plus c. So in this problem, b is equal to 1 because that's the coefficient to my x term. And then a we see would be equal to 3 because that's the coefficient of my x squared term. So then negative b over a would just be negative a third. That's my answer. I don't even need to find a and b. I actually haven't even bothered to find what they are because there's no need to. And that's going to be a very useful formula for you to memorize. But had they asked you to find a or b individually, though, then you would have to either factor or do quadratic formula. All right, so now we'll go to 25. So this is a bit of a callback to the old SAT, which I said used to have a lot more kind of advanced geometry questions that involve kind of manipulating complicated shapes. So I was a little surprised to see having 2 of them on this test when usually we have 0. But just in general, before we even read the question, as a general thing when you see a picture like this, a good thing to remember is that the area of an entire shape minus the area of the unshaded region inside of it would be equal to the area of the shaded region. And the same thing would be true the other way around. So the area of the whole shape minus the area of the shaded region would be equal to the area of the unshaded region. All right, so let's read this question. So in the figure shown, point O is the center of the circle. One vertex of the square lies on the circle, and the opposite vertex is point O. If the area of the shaded region is 36 pi minus 18, they want to know the perimeter of the square. So again, keeping in mind kind of that general principle I told you, we could be pretty reasonably confident that 36 pi is the area of my entire circle, and that 18 is the area of my square. And then when I subtract that, I'm left with the area of the shaded region. So I know that the area of the square that I have here is 18, and I want to find the perimeter. So if I want to find the area, we use the formula side squared be equal to 18. So for a square, it's side squared. So they give you the rectangle formula on the reference table, which is length times width. But remember, in square, length and width are equal. So side squared is 18. That means that side is radical 18. And then the question wants me to find perimeter. So this formula they don't give you, but perimeter, remember, is all the sides added together, which in the case of a square, is just 4 times the side length. So it'd be 4 radical 18. And that would be correct. You might notice it's not a choice. So you have 2 options here in terms of how to solve it. Since it is a calculator question, you could actually enter this into your calculator and then compare it to the choices. And then you would see that it's actually equal to choice C. Or if you remember from what we talked about with simplifying radicals back in the no calculator section, I could break up radical 18 into radical 9 times radical 2, since 9 is a perfect square factor of 18. So that would become 4 times 3 times rad 2, which is 12 times rad 2. Or again, since it's a calculator question, you could have just plugged it in. And I believe they equal something like, if I checked the other day, it was like 16.97 or something. So you'd see that 12 rad 2 and 4 rad 2 give you the exact same number. All right, so for 26, before we look at that, I'm just going to kind of do a mini lesson reviewing some basic factoring rules. So the first type of factoring I want to go over is just some basic trinomial factoring. This should be reviewed from Algebra 1. So just factoring equations that are in x squared plus bx plus c form. And notice I purposely said x squared, not ax squared. So I'm doing, this is for when there's a 1 in front of the x squared. So anytime you're factoring an equation in this form, what you'd want to do is make two parentheses with an x in each of them, since x is a square root of x squared. And then you want to look for two terms that add to the b term, which is the coefficient of x, and then multiply to c. So for example, let's say I had x squared plus 5x plus 6. I would put an x in two different parentheses, and I'd figure out, well, what are two numbers that multiply to 6 but add to 5? So I'd see that 2 and 3 meet those conditions. So I plug in plus 2 and plus 3. And if I did distribute that, that would indeed confirm. I would get x squared plus 2x plus 3x plus 6, which would be x squared plus 5x plus 6. So that's pretty basic. The way that they can make this question slightly more advanced is that they might use higher powers for your variable terms. So what they would do is they would give you a higher even power in place of x squared, and then your x term would just be half of whatever that higher coefficient was. So for example, another variation of this question, which is very similar. So instead of giving you x squared plus 5x plus 6, it might give you x to the 4th plus 5x squared plus 6. So you notice here I have an even exponent for my leading term, and the leading term is a term with the highest exponent. And we see it's twice the coefficient of my other variable term. So to factor this, I would do the exact same thing I did before. The one difference is instead of putting x in each parentheses, I put x squared in each parentheses. And then I just, again, find two numbers that multiply to 6 and add to 5. And again, that's 2 and 3. So it'd be x squared plus 2 times x squared plus 3. And again, if I distribute that, I would get x to the 4th plus 3x squared plus 2x squared plus 6. And again, I could have done x to the 6th plus 5x cubed plus 6. So again, I notice I have that even exponent for my leading term, and then half of that exponent for my second term. So then in each parentheses, instead of putting x, I would put x cubed. And this would keep going on. And again, I'd have x cubed plus 2 times x cubed plus 3. So that's kind of the first general factoring rule I wanted to go over. So trinomial factoring with the 1 in front of the leading term, but when the exponent is higher than 2. So when it's a bigger even number. And the second factoring rule that's going to be helpful for this question is difference of perfect squares. So the general formula for that is x squared minus y squared is equal to x plus y times x minus y, where x is a square root of x squared, y is a square root of y squared. So to give you kind of two examples, so if you had x squared minus 16, that would factor into x plus 4, x minus 4, since x is a square root of x squared and 4 is a square root of 16. And you just notice I have to do one positive and one negative before the 4. Similarly, for 4x squared minus 36, I would have 2x plus 6, 2x minus 6, since 2x is the square root of 4x squared, and 6 is a square root of 36. So with all that being said, now we'll take a look at number 26, and we're just going to apply those same two rules to this question. So they give us the equation x to the 4th minus 8x squared plus 16. So again, we could think of that as the same thing as x squared minus 8x plus 16. We're just putting an x squared in each parentheses. And then we're trying to figure out what are two numbers that add to -8 but multiply to 16. So the only ones that fit that condition are -4 and -4, because -4 plus -4 is -8. -4 times -4 is positive 16. So you notice I have two factors at x squared minus 4. So Roman numeral 2 actually shows us that same meaning. So the square there means that I have that factor repeated. So 2 I know is definitely right. So I could get rid of choice D and I could get rid of choice A. So now it's a matter of seeing if 1 also works. So you might notice my x squared minus 4 looks awfully like my difference of perfect square rule that I just showed you. So then these could each be further factored into x minus 2, x plus 2, because x is a square root of x squared, 2 is a square root of 4, and then another x minus 2, x plus 2. So once again, I kind of have two x plus 2 factors and two x minus 2 factors. So I square each of those. So then 1 would be correct also. So then C would be my final answer. Another thing you could have done that doesn't involve algebra, it's more of kind of a test-taking strategy that you could do to confirm that it's right. It might be a little time-consuming, is you could actually plug in any random number for x. And if you plug in any random number for x into your original expression and plug it into Roman numerals 1 and 2, you're always going to be equivalent. So for example, if you were to plug in 1 for x, I believe you get something like 9. It's like 1 minus 8 is -7 plus 16 is 9. And then if you plug 1 into choice 1 and to choice 2, you would get the same number. And that's going to work for any number that you do. All right, great. So now we'll move on to 27. So this is similar to number 19, except we actually have to do kind of math involved in this one. This was that question that we did with the exponential versus linear. So there actually is a formula that you want to memorize for exponential change with percent growth. So that formula is y is equal to a times 1 plus p over 100 to the x. So a represents your original amount, and then p is the percent change. So for example, suppose you have a starting population of 50, and then your growth is 10% of year, and y is your population, and x represents the number of years. So the way you would represent that algebraically is you would do y equals 50, so that's my starting value, which technically is my y-intercept, 1 plus 10 over 100 to the x, which ends up simplifying to 1.1 to the x, because 10 over 100 is 0.1. And that's how the equation would be represented. And just so you know, for percent decrease, when you're going down, it would be the same thing, except it would be 1 minus p over 100 instead of 1 plus p over 100. So taking a look at this question, they tell us each year the value of an investment increases by 2.5% of the previous value, and the initial value is 500. And they want to know which equation gives us the value of the investment in dollars. So again, we're just going to plug in values into that formula. So A is my original value, which is my 500, and every choice does that. And then I'm going to have my 1 plus, and my percent change is 2.5. So I'm going to do 2.5 over 100 to the x. And it ends up being 1 plus 0.025 to the x. And then finally, we end up with y is equal to 1.025 to the x. So choice B is correct. And that's a really important formula to know. And just kind of going back to 19, I know they didn't ask it for here, but if we wanted to write the formula for this, I know we don't have the initial value, so we could just call that A. In this case, it was going up by 3.5%. So it would look like this. And we would end up with y equals A times 1.035 to the x, where A is the original value. So it's the same thing. So basically, when you're going up by a constant percent, you're actually multiplying by a constant value. And that's kind of a key feature of exponential equations versus linear equations, where you're adding or subtracting a constant. All right, so number 28 is also a variation of a pretty common question type. So I'll do kind of a little mini lesson on that. But in general here, the idea is that they're showing you these two equations in ax plus by equals c form, as we see here. And we need to tell you and you need to give the number of solutions that the equation has. So this is a common question that shows up in other variations of this question. They might tell you how many solutions it has, and then have one of these terms like the 5 or the 12 or the 60 being missing and have you find it. But either way, it comes down to certain basic concepts that you need to know. So we're just going to go over those pretty quickly. So in general, if you ever have equations that are in ax plus by equals c form, there are three possibilities for the number of solutions that the system could have. So the first possibility is that they have an infinite number of solutions. So this would mean that they represent the exact same line. So one equation is basically the exact multiple of itself. So it's basically you're putting one line on top of itself. They have the same slope and the same intercept. So the long way to figure out if the equations have infinite solutions would be to actually rearrange each of them into y equals mx plus b form, but there's no need to do that much work. The quickest way is just to see what are you multiplying everything by when you're going from the top equation to the bottom one. So here I see from 3x to 6x, I'm doubling. From 7y to 14y, I'm doubling. From 10 to 20, I'm doubling. So since everything is doubled, I have an infinite number of solutions. It's the same line. There's no need to rearrange these into y equals mx plus b form. They have the same slope and same intercept. The second possibility is that they have no solution, which again, remember we talked about before, means that they would have parallel lines. So this would mean that their slopes would be equal, but not their y-intercepts. So again, you could rearrange the equations and see which have the same slopes and different intercepts, but there's no need to do this. So the quicker way to check for it is you want to see that the x and y terms get multiplied by the same thing, just like with infinite, but that the non-variable term or your constant term is multiplied by something different, because that would signal that the intercepts are different. So if we look at this example here, we see just like before, 3x is double to 6x and 7y is double to 14y. So I know my slopes are equal. So it's either no solution or infinite solution, but my 10 though is not doubled. So you see I tripled it. So this means I must have a different y-intercept. So there's no solution. The lines have the same slope but different intercepts, so they never intersect. And then finally, the third possible option is that there's just one solution. So this means that the lines actually intersect, and they intersect, so they must have different slopes. And again, the way you could confirm this is you could see that x and y are not multiplied by the same number. So in this example, I see that my 3 is doubled to be 6x, my 3x is doubled to be 6x, but my 7y is not doubled to be 14y, so it's tripled. And then the y-intercepts are just irrelevant in this one. So now let's take a look at question 28. And we'll figure that one out. All right, so right away I could get rid of choice C. That's never going to be a possibility on linear ones. That can be on quadratics, but for linear, it's going to either be A, B, or D. So the first thing I'm going to do is see what am I multiplying my x terms by. So I'm just going to divide my second x term by my first x term, and I end up getting negative 12. So I see my x term was multiplied by negative 12. 5x times negative 12 is negative 60x. Now I'm going to do the same thing for my y term. So 12y divided by negative y, again, is negative 12. So I know I have equal slopes, so B is definitely out. It's either going to be 0 solutions or infinite. So now it's going to all come down to this last term, my constant term. So if I do negative 108 divided by 9, once again, I get negative 12. So everything in the top equation was multiplied by negative 12 to give me the bottom equation. Therefore, I have the same line, so that's an infinite number of solutions. But had this been any other number but 108, then it would have been no solution, assuming that the x and y terms were the same. All right, so we still have like 6 minutes left. So yeah, I think we're just going to finish off with these last two multiple choice questions, 29 and 30, and then that should get us to about 8 o'clock, possibly a little bit over. So 30 is a really quick one. 29 might take slightly longer though. All right, so 29, I just want to go over two pieces of background information that will make this question more manageable to do. So the first thing I want to go over with you is the point slope formula for linear equations. So we've already talked in the other webinar more about the y equals mx plus b form of linear equations, and that's the form you're most often going to work with. You actually can use that formula for this question, but you're going to have to end up doing more distributing. So this is actually going to be a quicker way of solving this particular question, but it's not necessary to know, but it's going to make your life a little easier. So the point slope formula for linear equations is y minus y1 equals m times x minus x1, which you can then rearrange into y equals m times x minus x1 plus y1, where x1 and y1 just represent two random points on the line, and m is a slope of the line. So for example, let's say you had a line with a slope of 2 that included the points 4, 8. If I wanted to put that in point slope formula, then I would say y minus 8 is equal to 2 times x minus 4. And I could add the 8 to the other side to get y is 2 times x minus 4 plus 8. So that's going to be helpful for this particular question. Again, you could solve it in y equals mx plus b form, and then you could just kind of distribute the choices to see which is equal to that, but it's just going to be simpler to memorize that. And then the second aspect to this question involves kind of translating this into a linear equation or finding the slope in the context of a word problem. So sometimes you're going to have to find the slope in the context of a word problem where real life units represent the coordinates on your line. So I gave you kind of a mini example here that's similar to the one on your test. So suppose a gardener charges a flat monthly fee plus an hourly rate per hour worked. So that would be a linear function because it's a constant rate per hour. So let's say 5 hours of work costs $350 and 7 hours of work costs $450. So then I could figure out that 5, 350 and 7, 450 would be coordinates on the line that represents the graph of money versus time. So again, I'd always put time on the x-axis and money on the y, because you always do y as a function of x. So I'm doing money as a function of time, not time as a function of money. And generally, time tends to be an x coordinate anyway. So then I would find the slope, which you remember hopefully from our last webinar. Slope, remember, is y2 minus y1 over x2 minus x1. So it's basically the change in y over change in x. So I would do 450 minus 350 over 7 minus 5, which would give me 50. So the slope is $50 an hour. And I could also see that that makes sense, right? Because from 5 hours to 7 hours, I went up $100 in 2 hours, which means I went up $50 per hour. So if I wanted to write that equation in point slope form, I could do y minus 350 equals 50 times x minus 5. Or I also could have done y minus 450 equals 50 times x minus 7. It's actually up to you which coordinate you want to work with. So in this case, it's just going to be the random coordinate that the answer choice happen to use, but there's no reason why like one is better than the other. It's completely up to you, but the slope though has to be 50. All right, so now let's look at this question, which is a very similar situation, but instead of relating time and money, we're relating temperature and width. So it says here, bridges have spaces between their sections to allow for expansion and contraction caused by temperature variation. This space is known as the gap width. The size of the gap width in inches is a linear function of temperature, T, in degrees Fahrenheit. For a certain bridge, the gap width is 2.875 inches at 40 degrees Fahrenheit and is 1.875 inches at 100 degrees Fahrenheit. So we want to know which defines a linear relationship. So again, if I'm going to do this as a graph, I would have my temperature on my x-axis and then my width on my y, because it's width as a function of temperature. And also just looking at the equations, I see my width takes my y value, my t takes my x value. So I would say my two coordinates on my line then would be 40, 2.875, and then 100, 1.875. So then I'd find the slope of the line the same way we did before. So 2.875 minus 1.875 over 40 minus 100. And you end up getting -1/60. So C and D are out. And then just using point slope formula, remember I'm subtracting the x value of one of my values from x. So one of my x coordinates was 40. So A shows me the correct sign. B reverses that. Also, another way I could have done this without doing any algebra is actually just plugging in numbers. So I know when I plug in 40 for temperature, that my width needs to be 2.875. So if I plug in 40 to this, I get 2.875. And likewise, if I plug in 100 for temperature, you would get 60 times -1/60 is -1, plus 2.875 is 1.875. So A is actually the only choice that would work for both points. All right, and then we can look at number 30. So number 30 is actually a variation of the exponential change formula that we saw, just without the exponent. So for just regular percent increase questions, original times 1 plus p over 100 is equal to your final value, where p is the percent that you're going up by. So in this case, they told me that the number of books in a library went up by 30% from 2002 to 2014. There were X books in the library in 2002. So which expression represents the number of books in the library in 2014 in terms of X? So X is my original. So I would say X, and I do 1 plus 30 over 100, which ends up being X times 1 plus 0.3. So it's just 1.3X. So C would be correct. All right, and that was actually it for the multiple choice, and it's already 8 o'clock. So I guess we could stop there. All right, so thank you everybody for coming today, and I guess we'll be done. Bye, everyone.